important for the operations. So as said, once now we were building the air conditioning. The air conditioning may sound like detail, but is absolutely crucial for the functioning and the operation of the telescope. And this is actually very, very massive. This 80-meter high dome is a huge volume of air that we need to keep at constant temperature during the day. And you see the massive air ducts here, which you can actually walk inside them. They're very big. These are the fingers to recycle the air from top to bottom of the dome. And you see also support equipments outside of the dome. These are the air dryers and the chillers to condition the air. So all of this is about half finished and progressing at a good pace. Inside what is also happening is absolutely crucial at the moment is the cabling. So what you see here is of course the back of M1, and you see people here on the lift actually putting together the cable trays. And I like this picture because it gives you a sense of scale of how large is the M1 compared to human people. What you see also in this picture, again, the M2 crown here on top, the two laser launch telescope platforms, and here the also massive crane here, the dome crane, actually quite crucial because that's the crane that will allow us to do all the handling of the big pieces, including the instruments, to put the instruments on the platform. And we'll use this very big crane. So this is all actually installed and already working. Now, this view here is what is happening inside the M1 cell. So people are installing cable trays. Here, what you see is also where we will have all the cabinets for the electronics of the control and the sensors of the M1. So we have one cabinet for 7 segments for one flower. So we have about 110 cabinets to build. So they are being built at the moment. They're being populated and cabled and getting ready to be installed into the M1 cell at the moment. And what you see here being built is actually the computer room, all important computer room, of course. So that's the floor being built. So in terms of progress, so we have about 40 kilometers of cable trays to install. So this is 30% done. And the cables, we have 540 kilometers of cables to put in. So that's actually it takes a long time. I think we have at the moment 70-80 people working non-stop on this, and it takes time. But this is progressing well after an initial quite a lot of delays. Now this part is really moving along very well. Below, what you see here, this view very important, is below the telescope. So when you're at that floor, you are below the 3,000 ton of steel. And what you see here on the right hand side is one hydrostatic bearing. And a few weeks ago, the load was transferred from temporary support to the actual hydrostatic bearings. You see here the hydrostatic bearing, and here there is the very thin oil film that is onto which the telescope is going to rotate. So this is the outer ring, the outer rail. This is the intermediate one, as there is another one inside as well. So all of this is getting ready. This is not yet moving, but it's getting toward this. So this is a bit of backstage thing that probably you will never see even when you go there. Of course, not only you need to have the pads and the bearings, but also you need to have all the pumps and the filters for the recycling of the oil. And all of this is actually assembled and being tested at the moment. So there's a lot of progress as well here. And also I take the opportunity of this picture to show this is actually the seismic isolators here. And actually 2 weeks ago, we had the first test of what happens in case of an earthquake. In case of an earthquake, the telescope is unclamped and falls onto a massive isolators to decouple the telescope from the ground. So this has been tested. All the 3,000 tons fell a few centimeters down, and I was not there, but apparently it was very impressive. So this has been tested. So that's really good. Now, what is happening on the side of the glass, let's say? So this is happening both in Europe and in Chile at the moment. So just a short recap. So that we have here the primary mirror, the M1 39 meter, 800 segments, the M2 convex on top, which will be installed M2 crown. The light goes through. There's here in the hole into M4. There's the intermediate focus goes to M3, which is a 3.8 meter concave mirror. Then light is reflected to the M4, which is 2.4 meter deformable mirror. So the largest deformable mirrors ever built. And then the light goes on to M5, which is the fast tip tilt mirror made of silicon carbide and sent to here to either platforms, either on this side or this side. So the whole assembly M4 and M5 can actually rotate inside the tower and send the light in either direction. Here you will have the prefocal station, and the platform and the sense instrument will be positioned. And what I'm going to show in the next slides pictures of all of this and where we stand with the construction of all of these elements. So first, a recap on M1. M1 is actually a very complex machine in itself. So we have in total 930 segments because we have a whole sector, spare sector, because we need to exchange the plans to exchange 2 mirrors per day. So we need to have for recoating. So we need to have spare mirrors. So we are ordering 931 M1 segments, and we have a few spare blanks as well. So we have we have 2 edge sensors per edge. So in total, we'll have edge sensors of 4,500 edge sensors in total. With the nanometric accuracy in 3D, we have very complex M1 segment support that allow to actually move the segment and distort the segments a little bit. We have 2,500 segment activators here to position to nanometric accuracy each segment, and a lot of auxiliary equipment, sensor, master, dummies, card stands, and everything to do all the installation maintenance. And all of this is done mainly by those companies. I mean, Safran Reosc, of course, French, has doing all the polishing. Schott, which made all the blanks for the segments. PI, who made the positioning activators in Germany. VDL, we did all the support in the Netherlands, and the famous consortium, which is French-German consortium, doing the positioning, the edge sensors. So M1 production. So all the blanks were produced by Schott. The contract is actually finished. All the segment supports by VDL are finished as well. And you see here a lot of them in the background. You see also all the positioning activators made by PI. They're all finished, and they are already in Paraná. So those pieces of equipment are actually quite extraordinary. They have 2 nanometer accuracy with the 15 millimeter range. So this is very remarkable, essential for the ELT to function. The edge sensors by Macro Epsilon, they're all finished, and also are all of them in Paraná. The production of the M1 segments itself. So you see here this chart that we try and keep up to date as much as possible. So we have here in blue what you see, all the segments that are already in Chile, they've been shipped. In green, you see all the segments that are still in France, but packed and ready to go. So what you see here in between the green and the blue, we have the outer part of the mirror that's actually completed. And in yellow, you see the segments that are in production at the moment. The round ones have not been cut as hexagon yet, and the hexagonal ones here are already cut. In total, we have about 400 segment assemblies that are in Chile already. 260 of them waiting for shipment. 80 of them in production, and Reosc is producing about 1 segment per day, and a bit less now than 200 still to be polished. So when the segments are finished, they are put into containers. They are shipped in batches of 18 in dedicated boxes and dedicated containers that are unconditioned, and they're shipped via ship at the bottom of one of these big container ships. And they, after a long journey, they arrive in Chile. This was the arrival of the first batch of 18 segments, I think 2 years ago. And every one of these shipments is actually a high risk operation. So we are really following very, very closely. We've had some close calls already, and we're really following closely what's happening. It's very, very critical, as you can imagine. So once the segments arrive in Chile, we have actually built at Paranal a plant that actually is treating the M1 segments one after the other. After they arrive, when they arrive, they go into this big room. They arrive on the left hand side here through this door, this one segment in a box. They get inspected. They sometimes adjusted, and then they get cleaned. So this is the cleaning, washing, stripping unit that will also later on in operation remove the coating. And here the two cutting units for the segments. You see here one segment being extracted from its box, and this is a movie that's supposed to start but is apparently not starting. I was supposed to show you the coating, but you can see this movie on the ESO webpage. I can give you the link later. It's quite nice to see the coating machines doing the coating of those segments. Once the segments are verified, coated, they are put into boxes with the labeling and all the history as well, and they're stored at the moment. And we have a lot of segments, and that's waiting for the telescope structure to be finished for installation. Very important piece of equipment here is the M1 segment crane that you can see here. So here you see this will be, this is being tested in Europe. So this is the outer edge of M1. This is the crane that will be permanently installed. And this is the extension to the outer ring to be able to extract the M1 segments. And here you see a testing of the crane. It has to go very accurate and very smooth. And this is a mastomy. And instead of this in operation, what you will have is those equipments. So this is the what we call the SEN, the segment manipulator. We will have two of them that we will use to first, in the coming years, install all the 800 segments, and later on in operation, be able to extract the segment, so that it can be cleaned and recoated. And what you see on the right-hand side is what we call the local coherencers, very important piece of equipment as well. Every time we will exchange a segment with a new one, we will do the local coherencing, so that you have small interferometers here on the edges, and so we will reposition very accurately each of the segments. Now M2 is a remarkable piece of glass. It's a real jewel. This is the most concave 4-meter mirror ever built. You see it here being inspected. M2 polishing is completed with excellent quality, 60 nanometer reference error. The cell also was ready. The system test was granted middle of last year. Then it was shipped to ESO in France, and then the M2 mirror was integrated into its cell, and it has gone through a whole series of tests at the Safran ESO, and there was test made also with the telescope control system to be sure that all the interfaces are fine and we can control the mirrors exactly the way we want it. And here in this, that's what you see here. This was actually M2 on its cell during an interferometric measurement. This is where M2 is at the moment, waiting for transport later this year. It's in a box, and we're preparing for transport probably around the summer this year. M3 is has finished its 5th run of polishing. It's all going fine with better than 2 micron error RMS right now, and it's waiting for its first interferometric measurement. That should come in the coming weeks. The M3 cell is also integrated. All the passive supports, the Wiffle tree are being tested at the moment. It's in advanced stage of assembly and testing, and should be ready in the coming weeks. So all fine on M3. Very important piece of and quite crucial piece of equipment for the ELT is the M4 deformable mirror. As I said, M4 is the largest deformable mirror ever built, and it actually the construction the contract started in back in 2008. That was the very first contract that we passed because of all the risks and the difficulties to do this. So what you see here is one of the 6 shells. It's a segmented mirror which this is the back surface, and with all the little magnets being here glued. So this is exactly the same technology than the deformable secondary at UT4 or the VLT, but at a much larger scale, and with some important differences that I will tell you about. So this is one of the shell in inspection. So we have 12 shells. We have 6 2 sets of 6, so that in case one breaks, we can replace them because they are very fragile, but they're all finished and very good quality. So what you see here is on the right hand side is the silicon carbide reference body for the M4. So this one's also finished, and one very important step was to actually glue all the membrane interface and the tiles. So this is done. That was done by ADS. This is now the back side of the reference body, where you see here, these are what we call the tiles, where all the actuators are. So this is a very modular design, where you can actually exchange a tile, and in case some actuators are dead. So this is really made for easy maintenance. So this is all finished, and you see all the piping here, because we have a lot. Of course, it dissipates a lot of heat, so we have a lot of cooling. And one of the main difference we have with this mirror and other equipments is that this is no liquid cooling, but we have a gas cooling to avoid any contamination of any mirrors in the telescope. So that's a very important difference. So the M4 is actually now finished. All the scientific shells have been integrated, as you can see on this picture. So the mirror is now actually being tested very heavily, and in the coming months, we will have a whole campaign of calibration and testing in Italy. So this is all going very well, and we're very happy because that was really a very important milestone. So this is now, you see another view of the M4 actually finished on this test stands at Optica. Actually, this was during the climatic testing in the climatic chamber. So all of this is M5 tip-tilt mirror, silicon carbide. The polishing run is now the number 7 is completed, and it all looks very, very good. For a long time, it was a very, very high risk, because it's the largest silicon carbide mirror ever built out of 6 petals. So it's very, very delicate. So what you see here is the first interferometric test of the mirror. So it's already quite shiny, and we have a very good surface already, and looks very promising. So we're reassured, and things are progressing well. There's no sign of delamination, and everything's going fine. The M5 cell itself, doing the tip tilt here, was in our lab in Garching until recently. It's also went through a lot of tests with the telescope control, and to really verify that we could control it the way we wanted. And so all the tests are very successful, and now the M2, the M5 cell is now in a box and ready to ship to Chile, and it will be shipped together with M2 later this summer. The M5, so M5, as I told you, is very delicate piece of equipment, and very fragile. So, sorry. Sorry. Yeah. Okay. Fine. So the M6 the M5 is we're building actually a second blank. So this is one of the petals of the second blank with a slightly different way of doing the CVD layer and important risk mitigation in case something goes wrong. And we have a even second mitigation, which is the smaller version of M5 in 0 that is actually being polished now in case something really wrong happens, so that we can. So this mirror, if we ever have to use it, we would not be able to do a lot of science with it, but we could commission the telescope. So this is a very recent view from a webcam, and now we're going to move of what is happening close to the focal plane and the instruments. I wanted to show this picture because what you see here is actually one of the NASMIT platform being pre-assembled here on outside of the dome, and this is hopefully soon going to go into the dome. To give you an idea of the size of this platform, it's really huge. So let's have a look at what's happened now on this platform close to the focal plane of the telescope. So this is of a 3D model of the prefocal station you see here on an empty platform. So the prefocal station is the station that really does all the wavefront sensing for the telescope, the standalone telescope, and it also holds the M6 that sends the light to the lateral ports. So this is actually the two prefocal stations are finished now. They are being tested at EDOM. We should go through acceptance before the summer. Now we're in a process of PAE at EDOM, and what you see here is what the view from the side of the light of the telescope. These three things here are these are covers to the three guide probes. So here behind this cover, what you have is these are the sensor arm optic box assemblies. They're all finished, they're done, and they're being tested right now. And you see here both the pupil and the image sensor for one of those probes. So this is all done. As I said, factory acceptance is ongoing, and PAE in Acceptance Europe in Q2 this year. Very important piece of equipment is the phasing and diagnostic station. So this is being assembled at the moment in the labs in Garching. So this is very important because it allows to do the phasing of M1, but also do the commissioning of the telescope before the instruments arrive and demonstrating the diffraction limited performance. So very essential piece of equipment of what's coming next, being integrated right now. Most of the optics have been received, and it's a bit actually quite advanced, about more than 70% aligned now. You see here this is phasing sensor, and this is the pyramid wavefront sensor here. Something that we don't talk so much about usually is the control system, because of course, as you can imagine, there's a lot of software behind the scene being developed. I wanted to mention this, that there's a huge amount of work and coding behind the scenes. So these are during the test of M2, M3. We really test all the control software with the hardware as much as we can to de-risk the next phases. So this M2, M3 test, this is M5 cell test with the control software. Now let's go briefly to the instruments. So this is an overview, not completely up to date, but it's an overview of all the instruments. So maybe I'll start with Morpheo here. You see this is the MCAO module. It will have two clients, Mikado and Harmony. It has, in addition to the telescope, it will host two deformable mirrors to do multi-conjugate adaptive optics. First client is Mikado. You see our imager, 0.8 to 2.5 microns, has two field of view, one of 53 arcseconds, the other one of 20 arcseconds, and this also offers single normal long slit spectrograph. Second client will come later is Harmony, the integral field spectrograph, and then will come before that. We'll have Metis coming, which is the imager element band, also single slit spectrograph, and also hosting an IFU at the resolution of 100,000. And on the other side, we'll have first Mosaic. Well, if I go in order of contract signature, there was first Andes, is high resolution spectrograph. It's a resolution of 100,000 from U2K, And then Mosaic, that of course in France we know very well, the multi-object spectrograph for the ELT with 300 fibers, 8 IFUs, and resolution between 5,000 and then 20,000, covering from visible blue to HMAT. And in the future, also community is preparing for the planetary camera, PCS, for which we are doing more technology developments for the deformable mirrors at the moment. So if we go for the status of each of those instruments, so for the imager, for Mikado, see a few pictures here. It's in full swing construction at the moment. So you see a flying cryostat here that we had a few months ago over in the sky in Bavaria. So the cryostat is ready. It's now being populated. This is the central wheel mechanism with all the filter slots. Actually, all the filters have been now accepted. And all of these mechanisms are going through heavy testing in the test cryostats at the moment. The Mikado team has something with flying and doing risky stuff. I don't know why, but so this is really a very scary moment. I think it was last week of the AO Scow bench arriving at Lyra at Les Communs in Nodon. Really nice to see. And this is an image of the Scow bench. So yeah, congratulations to the team for this milestone, and all the best for the integration. So now also something that maybe not many of you know is that we're also preparing all the tools for the observation for the astronomers. So this is the phase 2 tools to be able to prepare the observation. So this is also progressing quite well. On the side of METIS, so the mid-infrared imager and spectrograph, also in full swing construction at the moment. This is the cryostat being tested. So the test actually is finished now. It went very well, and the inside of the cryostat is being actually populated. This is a very delicate piece of equipment. This is the chopper, because the chopping for the mid-infrared imaging inside is inside the cryostat. So that's a very important, and lots of tests have been happening on this. This is the massive cryogenic derotator here that was that just had finished the lifetime testing in our labs at ESO, and it really didn't show any signs of wear or whatsoever. So it's really promising, very good. Also common for optics box here is actually all the piping and tubing are being installed. So this is also going on full speed. That the LM spectrograph peak of wheel being tested. Also lifetime testing at the moment, and this is the calibration in the carbon fiber bench also. So this is all really going very well, and with the usual hiccups when you do the assembly of those very complex instruments, but really I would say going as good as it can, and it's very complex. Morpheo, so the MCAO module that will serve both Mikado and Harmony. It passed the optics FDR a few months ago. The two large deformable mirrors passed the FDR. They are actually in manufacturing. We already have one shell, one reference body, so it's really going quite strong on this as well. At the moment, the big phase is to tender the big contracts for the structure. These are very big structures, and the good news also that the FDR was held in February, and the first FDR only was held in February, but I was actually reviewing most of the adaptive optics aspects, and it's really that was quite successful. So it's very good. On the side of Harmony, so many of you know, so the near-infrared diffraction limited IFU, so it went through quite difficult times, and so in the past year, the team has really worked very hard on the rescoping the instrument, simplifying it without actually losing much capability. So we're in the final phases of this rescoping at the moment. So it will go from actually this node up to 750 nanometer to 2.5 micron, and with the two plate scales, 6 mass and 25 mass. It will be fed by Morpheo MCAO and the SCAO, and it will also have high contrast. So harmony now should be the redefinition phase should be closed very soon, and restarting normal work towards construction in the coming weeks. Andes, so Andes, the high resolution near-infrared, the visible and near-infrared spectrograph at the resolution of 100,000. So the Andes status is that it's an ongoing subsystem PDRs, and it's preparing for the final PDR at the end of this year. So here you see Andes is actually a very modular instrument, which has actually making use of the also the CUDE room at the bottom of the telescope to host the RIZ and YGA spectrograph, and also the calibration unit. And you see here that's an old picture of the construction of the ELT, and this is the CUDE room where the most of the equipment of Andes will be hosted. So at the moment, preparing for PDR. And last but not least, Mosaic, the multi-object spectrograph for the ELT. So it had in the system architecture review, and now is working full speed for PDR. The construction contract was signed actually on 1st of December, and the whole team is working towards PDR. And this is rendering also the infrared spectrographs and the visible spectrograph, and it also have a ground layer adaptive optics. In terms of global schedule, before I finish, I wanted to show you this. So we are now in 2026. What we expect in the near future, the cabling, etc., and air conditioning is going strong, and also hopefully moving the telescope soon, testing the structure, aligning it, etc. So that is what is going to come in the coming year. We are aiming at provisional acceptance of the dome in 2027, and we will see how things go, but it should be in 2027. And when this is this milestone is done, then we will start populating the telescope with glass. The M2, M3, M4, M5 will be installed in M1 slowly, one segment at a time, and that should allow us to start commissioning towards the end of 2028 with the goal of achieving first light in March 2029. So we have a bit of a buffer here in between the first light and the time when we can actually welcome the instrument on the platform. So we will see what happens exactly in 2029. It will be a mix of finishing, commissioning, and getting ready to welcome the first scientific instrument here, and one after the other, the instruments will populate the platform, and we aim at having a first scientific light, so starting science verification for the first instrument by the end of 2030. Before I finish, I wanted to remind you, if you are not aware, that in order to prepare for operations and science exploitation of the instruments, we have since a few years ELT working groups, and if you're interested in those and working on sky subtraction, PSF, high contrast, calibration, etc., don't hesitate to contact me. There is room for work for everybody. I will finish here and try and answer your questions. So this is a recent view of the sun setting at Armazones. And maybe, I don't know if I can answer, this is a time lapse. Might be why we are going through questions, time lapse of what happened at the site in